value of the state would be some function of these features. So instead of right away computing a tabular value model, I'll compute weights for each of the features. So W1 times F1 plus W2 times F2 plus W3 times F3 is the value of the state. And so I will just now, the learning is no longer going to be just finding the value of individual state, but finding these weights. That's the connection between inductive learning, that whole thing that we did in the beginning of the class, and reinforcement learning, where you're winding up doing the learning of the action models as well as the states in this state variable representation of the states. Yes?
Yeah, I have a question. So, for the Bayes networks, when we did the empirical evaluation, we actually used the function and used calculus on it to maximize the likelihood of the function. Whereas for multi-neural networks, we minimize the error. So here, are we saying that we are trying to?
So what are you minimizing here?
Minimizing or maximizing?
It's with respect to the unknown model. Okay, and it's basically, remember, it's a sequential decision problem. You're not, all Bayes networks, etc., are about state of a single world state. Here we are talking about multiple world states and connections between them. It's a much more interesting problem. So I just want to end this, even though it's a very high level, by pointing out that, as I said, DeepMind connection. Remember that, which is actually where there's Google poured this money into DeepMind in Cambridge, and all they're essentially doing is learning value representations and action representations for states using multi-layer neural networks. That makes deep learning. And it's deep mind because mind just doesn't learn a single pattern, it does sequential decisions. So they're essentially doing reinforcement learning with the state value representations and the state action representations in this parameterized form where the parameters are multi-layer neural networks. Okay, I'll stop there and I'll take 5 minutes to end this thing. Then you get to go. That's the ending. Okay. So, many years back, we started with a picture like this. You forgot, but I still remember. And we talked about how to generate an intelligent agent and what are the pieces in it. And I just want to kind of tell you approximately which pieces and what techniques correspond to. Okay, so for example, we talked about how to represent the knowledge about your state and how the world evolves. That's where we looked at logic, and we also looked at Bayes networks. That's representation. Of course, you can also do atomic models, which are just MDPs, or A-star search, where you just don't have a structure to the state. The state is a black box. That's always possible. Then these models, how the world evolves and what my actions do, I can handwrite, which is what we started from in the beginning, either as A-star's child generator function, or MDP's transition function, or logical statements, or towards the second part, we talked about how to represent, how to learn structures in each of these languages. How do you learn Bayes networks? Bayes learning. How do you learn logical sentences? Decision trees. One example. Okay, and how do you learn sequential decision making? I just very quickly pointed out the reinforcement learning sides of the point there. And we also talked about if I have the model, how to do the optimal action. That's where we looked at A-star search. We looked at planning, which is basically operator-based planning, which is like where the states are not black boxes but have structure in them. And then we also looked at satisfiability. That is also basically structured descriptions of states. And then we looked at MDPs, which I forgot to mention here, because search in MDPs is value computation, value iteration, and policy iteration. So that's how those pieces are. And the one big piece that we did not talk much about is how do I take the environment and sense its state using sensors? That's very important. To do robotics, you need to be able to sense. typically that also requires actually a lot more signal processing back. That's part of the reason I didn't do it here. I just do a very poor job of it. Okay, but converting the world into sensory information basically involves signal processing. And similarly, how do I change the world? Depending on the effectors, if it is a physical world, of course I have to, notice that sensing is easy if my agent is living in on the web. Because then, the sensing is basically checking whether a file is up or not, whether a particular link is up or not. Those are easy to sense. The kinds of sensing that's hard is like visualizing, by looking at the image and seeing what people are doing in front of you. Those are the physical situations, we didn't do that part at all. Okay? And similarly, we didn't do effectors. And furthermore, that's basically manipulation. Again, for something like web, it's like I just told you when we did planning, I can put A on B, and then you just assume that somebody will do the actual dirty work of putting A on B. But actually grasping A and putting it on B requires manipulation. That's an important part, but we did not do that. Okay? And then the other thing we didn't do is we looked at the world as if it is made up of a single agent. If it's a single agent, there is no point for the agent to talk to the environment. What does it say to the environment? Nothing. If you have multiple agents, they would like to communicate. Communication is actually a kind of a perception of the environment, which meant we did not do natural language processing because we are not going to talk to the world. We're going to talk to people, right? Okay? So we are essentially, that's the perception part we did not do. So this is actually kind of giving you, this is the setup from the textbook. The red parts we did not do, the green parts we did, okay, in the textbook. So if you want to take another course, actually, yeah, so that's pretty much, and some of the ones in between red and green we kind of touched on, like things like reinforcement. To make a course demanding enough that you have no sleep, I need help. And so a lot of people helped. So that's of course Anaga, and you know that. And there is this guy who is taking the video. He's undergrad TA Daniel, Vayatari, another undergrad TA. Those were actually paid, but of course they did more than what they paid for. And then there are people behind the scenes who did free basically for you guys. Satya basically did 14 weeks of recitation for those of you who went there. I'm sure you would have gotten a lot out of it. Tathagata and Vignesh, that's Tathagata and that's Vignesh. They set up all your actual quizzes on the blackboard so that they'll work quite fine. And so you should thank them because the course would have been much easier without them. Okay? And then of course, before ending, I would like to talk about what all I talked about what all I covered, but then there's this whole point that it doesn't matter what you cover, it matters what you uncover. There's a bunch of Far Side cartoons about what I think I'm telling you, and I am depressed when I read your answers to see what you actually got. So really the question of course is what did you get as against what I think I taught. That's why I made you do the interactive semester review of some sort. And that's the word cloud from what are the kinds of things that you got out of it. And when after some number of semesters, after you got out of the really bad shock of the grade from the course, look back at what you wrote about what you learned from the course, and you'll feel good. I'm very sure. And this is my normal last slide, and I don't know whether the music will start, but let's see.
I hear it.
Well, imagine the Schindler's List music, but basically So, there are of course a large number of there are a large number of extra topics we could have done if we had time. And of course, if I did all the topics you wanted to do. For example, perception, as I said, I did not do. First order logic, I really wanted to do. I didn't do. Chittavarala, please don't tell Chittavarala about this. Multi-agent anything, it would have been very nice to do. I didn't get to do. More on reinforcement learning would have been good. CSP is a very interesting topic that is extremely close to what we did. I just skipped over it. You should read it, you'll understand. I could have used clickers more often because I gave you the clickers, and maybe would have been less demanding more often. But then Marvin Minsky says that with understanding comes a sense of loss. I don't know where this went. So Marvin Minsky basically says with understanding comes a sense of loss. So many of you, in unlike certain other courses, you have an idea when you came into this course as to what AI might be. And there was some magic hopefully involved with it for you, and I hope some of that magic is done. Okay? I hope that the loss is not just the loss about the magic of AI, not just the loss of sleep and loss of actual social time, but also at least some of the loss of the magic of AI. So I'll stop there. Thanks for showing up. I'll send you your